Okay, so we're going to start talking about systems of equations. And this is just going to be a fairly quick introduction to our systems of equations. Now, whenever we're talking about a system of equations, we've got a couple things to keep in mind. One of those things is that when we're looking at a line, every single point on any line every single point on this line is a solution to whatever equation this is. My apologies for traffic noise outside my window. Well, guess what? If I've got more than one equation, well, every single point on this line is also a solution to this line, which means that this point of intersection, this point where these two lines meet, this point is what we call the solution to the system of equations. So when I have two equations, when I've got two linear equations, I can find my answer by literally graphing the lines and finding the point of intersection. So you can find your solutions by graphing and finding that point of intersection. Now, this is one of the reasons why it's a fairly important skill to know how to graph lines and to graph lines accurately. If you're doing this by hand, I will say the downside of solving graphically is it's only as accurate as your graph is. So you need to be able to graph accurately in order to be able to solve an equation accurately this way. Now, we've got several different cases of systems of equations, and I'm going to run through some of these cases right now. So hopefully you might be taking some notes. I will. So when you could circle back to this if you need to take any other notes here. So we're going to talk about our three different cases whenever we have got a system of equations. And the first case is very similar to what that first graph that I just did. X and Y. I'll have my last case down here. And our first case is where I literally have two different lines and I've got two different lines. They've got different slopes. So I've got one point of intersection. I've got one solution. So in a lot of ways, it's easy to look at these as saying, okay, I've got one solution. This is called a consistent system. We also say that it is independent. I think it's A-N-T. I can't spell this morning for whatever reason. Now, what it means to be independent is our solution is, it doesn't matter where we start on the line, I've only got my one solution. So this only has one solution. And anytime, one thing that I want you to note is anytime I've got two lines that have different slopes, so I've got anytime I've got lines with different slopes, they at some point will meet. Now, since I said it that way, I hope that kind of leads you into what might happen if I've got lines with the same slope. And anytime I've got lines with the same slope, well, first thing I can find is I can find something that I could have a system where I've got two lines with the same slope. And if they've got the same slope and they're intersecting the y-axis at different places, I've always got this consistent, I've always got this difference. I've always got a distance in between them. These lines never, ever meet. So here I'm going to have no solutions. These are called, this is called an inconsistent system. An inconsistent system has no solutions. So these are going to be the same slope and basically we've got parallel lines. It's called, this is an inconsistent system. Technically it's independent, but that doesn't matter. Basically, all it means to be independent is that it doesn't matter where you start on the line to have your solution. Because I've got no solutions, it's still technically independent, but that doesn't really feed into our it's what's important here is remembering that it's inconsistent. Our last case is where I've got lines that again have the same slope. And I'm going to go with a negative slope this time. But essentially my lines overlap. So if my lines are overlapping, every single point on both lines is a solution. In which case, this is called a dependent system. So what's our solution? Well, that depends. What is our x? Well, if our x is right here, then my solution's right there. If my x is over here, my solution's right there. This one literally has an infinite number of solutions. An infinite set of solutions, I should say. Which is given by the equation of the line. So we've got three different cases where I've got one solution, no solutions, or infinite solutions. And most of the times, most of the cases that you're going to work, it's going to be a consistent system. It's going to have one solution. It's fairly easy to look to a graph and go, oh, there is my solution. Inconsistent means you've got parallel lines, they never touch. Dependent system means you have things that are, two equations that are in all things are basically the same line. Another way of saying this is another word that you run into. I don't think Alex actually uses this one, but it's sometimes called collinear. You don't need to know this particular word for Alex if you're using Alex to learn this. Alrighty, that's all I have for now, and I'm going to talk a little bit more in our other videos about how to go over or how to solve some of these.